What if infinity wasn't truly infinitely complex? What if the chaos of the endless could be tamed by a hidden pattern? Today we dive into a discovery so shocking, shook the very foundations of mathematics, and shows us how to solve the impossible. Welcome to my channel Kalki, where imagination meets AI. Here, we explore powerful ideas, creative tools, and the future of technology. Let me tell you a story of the problem that broke mathematics. In 1913, a poor Indian clerk named Srinivasa Ramanujan wrote a letter to Cambridge mathematician Godfrey Hardy containing some of the weirdest math ever seen. One equation claimed that infinity could be calculated exactly, not approximated, but precisely determined using a pattern that repeated every 12 terms. Even more shocking, he claimed that the sum of all positive numbers equals -1/12. How could adding numbers forever equal a simple fraction? This looked like mathematical madness. Infinity, everyone knew, was endlessly complex, unknowable, impossible to pin down. But Ramanujan was right. His formulas do calculate infinite sums exactly by recognizing that infinity has hidden structure. What seemed hopelessly complex was actually endlessly patterned. Today, modern theories like quantum field theory and string theory depend on his impossible mathematics. This discovery revealed something profound. Infinity isn't actually infinite. His insights unlocked a universal secret that transforms how we deal with any overwhelming problem. It's just very large patterns that our brains can't hold all at once. Instead of struggling with the whole of complexity, we find the repeating pattern and work with chunks. This is the power of chunking. Your brain chunks information all the time. You don't consciously process each letter in the sentence. You chunk letters into words, words into phrases, phrases into meaning. Your brain automatically finds patterns and works with meaningful units instead of endless details. Driving to work. You don't consciously control every muscle. You chunk familiar sequences into automatic routines, allowing muscle memory to take over, freeing your attention for navigation and decision-making. Learning any skill, whether it's playing guitar, coding, or cooking, you start with overwhelming complexity, but gradually chunk sequences into automatic patterns that feel effortless. The magic happens when you realize that everything complex is just patterns you haven't chunked yet. The chunking revolution shows us two profound truths about complexity. Every overwhelming challenge, from quantum physics to raising children, becomes manageable when you find its natural chunking structure. Complex systems gives repeating components, gives manageable units. The chunking principle reveals something even more profound. Different levels of complexity have natural saturation points where they must transform or break down. One-dimensional limits: a line can only fold so many times before it must become a surface. Try folding a piece of paper, no matter how large it starts. You can only fold it 7 times before reaching dimensional saturation. The line must become a plane. Two-dimensional limits: a flat surface can only bend so much before it must become a volume. Soap bubbles naturally form spheres because that's the 2D surface's most efficient 3D configuration when it hits saturation. Three-dimensional limits: physical objects can only compress so much before they must transform into something else entirely, like matter becoming energy, or individual systems becoming collective networks. This isn't just mathematics, it's how all complex systems work. When any system reaches its dimensional saturation point, it doesn't break down randomly. It transforms into the next level of organization, or break down to a previously stable state, following predictable patterns. The 12-fold secret. Ramanujan discovered something remarkable. Many natural patterns repeat in cycles of 12, and this connects directly to dimensional saturation points. This isn't coincidence, it's how complexity naturally organizes itself. Time: 12 months, 12 hours, 12-year cycles in many natural systems. Music: 12-note chromatic scale that captures all possible musical relationships. Growth: many biological and social systems show 12-phase development cycles.
Mathematics:
Ramanujan's infinite series showing 1, 2 plus 3 plus infinity equals -1/12 reveals that even impossible sums have 12-fold harmonic structure. Why 12? Because it's the smallest number that divides evenly by 2, 3, 4, and 6, making it the most organizationally flexible number. When systems hit dimensional saturation points, they reorganize into 12-fold patterns. When you're facing an overwhelming problem, look for its 12-fold structure. Most complex challenges naturally organize into roughly 12 key components, phases, or decision points. Here's how to apply chunking to any overwhelming challenge. Step 1. Stop trying to solve the whole problem. The human brain can't hold more than roughly 7 pieces of information simultaneously. Trying to grasp infinite complexity at once guarantees overwhelm and paralysis. Step 2. Find the repeating pattern. Every complex challenge contains repeating elements. Look for what stays the same while other things change. This reveals the underlying structure. Step 3. Identify the natural chunks. Most problems naturally break into 5 to... If you have more than 12, you're probably looking at subpatterns that can be grouped. If you have fewer than 5, you might be missing important components. Step 4. Solve one chunk completely. Master one piece thoroughly before moving to the next. Deep understanding of one chunk often reveals shortcuts for all the others. Instead of memorizing infinite vocabulary, successful language learners focus on the 1,000 most common words, which cover 80% of conversations and basic grammar patterns. They chunk the infinite complexity of language into manageable, high-impact pieces. Successful entrepreneurs don't try to solve every business challenge simultaneously. They chunk business development into phases. Idea validation gives minimum viable product, gives customer acquisition, gives scaling systems. Each chunk is manageable. Trying to do everything at once leads to failure. Professional musicians don't try to play entire symphonies from the start. They chunk music into phrases. Practice each phrase until it's automatic, then combine chunks into larger sequences. The infinite complexity of musical performance becomes manageable through systematic chunking. Nobel Prize winners don't understand all of science. They understand their field's chunking structure deeply enough to see new patterns. They work with manageable pieces of infinite complexity rather than trying to grasp everything at once. If this journey sparks something in you, come, let's explore more together. Subscribe to my channel. Thanks for watching. See you soon.